Hey guys, welcome to Homework Help for Year 6, Term 3, Week 8. On page 21, we're doing Set 5, Question 11. PQRS is a rectangle. Alright, so PQ is 16 centimeters. PQ is the length, this one here, and that is 16 centimeters. Now QR is equal to 12 centimeters. And PR, so PR is the length from here to here, and that's equal to 20 centimeters. Now angle PQT, so we start, let me draw this in blue, maybe you can see it, PQT. So if we follow the letters, you're gonna get this angle here, okay? So angle PQT, so this angle here must be 37 degrees. Now the question is, how long is SR? SR is this length here. That length must be the same as the top length because it's a rectangle. So that means that must be 16 centimeters. What is the size of SRQ? SRQ is this, so we go from S, we go to R, and we go to Q, so it's this angle in between. So basically, what is this angle? Well, this is the corner angle of a rectangle, and we know that all the corner angles are 90 degrees. So that must be 90 degrees. What is the length of the diagonal QS? So from Q to S. Now, we know that the diagonals of a rectangle are the same. So QS is going to be equal to PR. Both diagonals will be the same length. So if PR is 20, then QS must also be 20 centimeters. Which side is parallel to SR? SR is this one here, SR. Okay, which one's parallel to that one? Or must be PQ. So PQ. Is PR, this means perpendicular. Is PR perpendicular to QS? Now PR, where's P? I'm going to do this in maybe green. PR, that's that one. Is it perpendicular to QS? Meaning, do they meet at 90 degrees? No. The properties of a rectangle states that they won't meet at 90 degrees, so the answer is no. How long is QT? Q, from Q to T, so this one here. Now what we do know is that the diagonals of a rectangle cut each other in half. So you see this length SQS, the diagonal PR will cut this length in half. So what that means is that if QS is equal to 20, half of this must be 5. So QT must equal to 5 centimeters. Oh, sorry, not 5. 10. Half of 20 is 10. I don't know why I said 5. Okay, what size is TQR? TQR. So what's this angle here? Let's asking that one now. Now we know that the angle, this whole angle here from here to here is 90 degrees, right? Now this one was already 37, so 90 minus 37 will give us this remaining angle here, which is what we're looking for. TQR, so that's what we're looking, whoops. So TQR is this angle here. Alright, so we do 90 minus 37, what does that give us? 3 to 40, 54 degrees. Alright, there's all the answers for question 11. Question 12. Now this is a parallelogram, so you have to know how a parallelogram works, and then you can answer these questions. So first what I'll do is, I'm going to put the numbers in. KL, so KL is equal to 15 centimeters. So KL is this length here, and this is 15 centimeters. KN is equal to 8. So from here to here is 8 centimeters. And KM So KM is equal to 13 centimeters. What else we got? Angle K, this one here, angle KNM. KNM. So this angle here, KNM, is equal to 60 degrees. Alright. Parallelogram, meaning that these two sides are parallel. And these two sides are also parallel. What is the size of angle KLM? So let me put that in blue. KLM. So what is this angle KLM? So what's the angle there? So what's that angle? Okay. So what we know is that let me think. Okay, I'm gonna color this in red. Actually, I'll make it in blue. Okay, so what we do know is that this length here, this line and this line are parallel, and then you have a transversal line that goes through the two parallel lines, which means that you're gonna have some properties, right? So imagine if I have this angle here. This, you can see that it's an obtuse angle, and this is an acute angle. Remember, all obtuse angle plus acute angle must equal to 180 degrees. So if this is 60, this one must be 100. Must be 120. Okay, and now same thing here. So that's 120. So let me get rid of all these lines and put that in for 120. So this is 120. Now at the same time, you have these two lines, which is also parallel. This is parallel, and this is parallel. That's what it means to be a parallelogram. Okay, the opposite sides are going to be parallel to each other. And then you have this line, which is now considered to be the transversal line. So you have this setup. You got two parallel lines and a transversal line. So that means that this is an obtuse angle and this one is an acute angle. Obtuse plus acute must equal to 180. So if that's 120, this one must be 60. Okay, so let me get rid of these lines and write that in there. That should be 60 degrees. Okay, and I think that's what the question was asking. KLM. KLM is that angle there, so that's 60 degrees. Now next one says NKL. Where's N? NKL. No, that's not it. NKL, so that angle there. So, and we already worked it out, that's 120 degrees. Alright, next one is LN equal to KM. Now let me just do that in maybe black. LN, where's LN? LN is this one here. Is that line equal to KM? So are the diagonals of a parallelogram equal? Well, let's have a look. Here's a parallelogram. Diagonals bisect each other. It says there's nothing about the diagonals being equal to each other. They're only equal in a rectangle, not a parallelogram. Okay. What else? So that's the answer here is no. So I'll put that back in blue. No. Is KM perpendicular to NL? By the way, the word perpendicular, it just means that, so I'm just going to write over here. Whoops. When two lines are perpendicular, it means that these two lines will meet at 90 degrees. That's what it means. So these two lines, they meet at 90 degrees, so therefore they're perpendicular. Okay, and the sign for perpendicular is that thing there, which is written right here. There you go. So it's asking you, is KM, is that perpendicular to NL? So do the two black diagonal lines, do they meet at 90 degrees? Is this a 90 degrees? No, they don't. This only works for rectangles and squares and rhombus, not for the parallelogram, so that's a no. Now last one is angle LMK. LMK, where is that? Maybe this is a bit too much. Let me rub this out. L, we start from L, we go to M, and then K. Is this angle here equal to KMN? MN. Is this equal to this angle here? So is that angle here equal to this angle down here? KMN. Well, let's have a look. Diagonals bisect each other. Opposite angles. Nope, there's nothing about diagonals bisecting the angles of each other. So it's not, diagonals are not we call it angle bisectors. So it doesn't cut it in half. Okay. So no, the answer is no. Which side is parallel to MN? Which side is parallel to MN? MN. Let me see where that is. MN is this one here. Which side is parallel to that? Well, this one is parallel to it, which is, we can say that's KL. Or you can say LK, it's the same thing. How long is JM? JM. Alright. Now we know the diagonals bisect each other, so that means the diagonals of the parallelogram cut each other in half. So that's the same as that side here. Now JM is from here to here. Okay, so that's the distance M. We need to know the distance KM. Do we have a distance KM? I think it's given to us. KM is equal to 13 centimeters right here. So this distance is 13 centimeters. Let me just rub this out. This distance is 13 centimeters. So what's this distance? This should be half of that. So this should be 6.5. So this one, JM, 6.5 centimeters. Next one, WXYZ is a rhombus. Okay. WZ is 13. WZ is 13 centimeters. ZX, so ZX is equal to 24 centimeters. And angle ZWX, so this angle here is 135 degrees. Okay. Oh, and ZX. Oh, yeah, okay, we got everything. How long is ZY? ZY, I'll put that in blue. ZY is this one here. How long is this distance? Well, we know that the rhombus has all of the lengths to be the same. So if this is 13, this must also be 13. So that means ZY must be 13 centimeters. What size is angle XYZ? X, we start from X, we go to Y, we go to Z. So what's this angle here? Alright, we know that the opposite angles are going to be equal. Okay, so if that's 135, this is opposite angle, that must also be 135. Angle Y, WZY. WZY, where's that? I'll put that in green. WZY. So what's this angle here? Right, so we do know that these again are parallel. So that add to that must be 180. Okay, here's a let me just maybe if I draw it properly. Let's try again. Okay, we know that parallelograms, rhombuses have the opposite sides are parallel. So this line is parallel to this line, and you have this line here. This is transversal. Now we know this is to be 135 degrees, which means that this is an acute angle, that's obtuse angle. So this angle here, the one I'm coloring in, plus with 135 must be 180. So 180 take away 135 should give me 45 degrees. So that must be 45 degrees. Is WY, okay, where's WY? Let me just rub this out. Let's put in black. WY is here. Is this one equal to ZX is equal to this one? No, they're not. Okay, you can also go to rhombus and have a look here. Where's the rhombus? Here it is. Diagonals are perpendicular, yes, which means they meet at 90 degrees. Diagonals bisect the angle at the vertices. Oh, okay, but there's nothing about it being diagonals are the same. Not like, for example, a rectangle. Diagonals are equal. It doesn't say that for the rhombus, so we can't say that the diagonals are going to be equal. So these are the diagonals. Y, WY, and ZX. Are the diagonals equal? No, they're not. Which side is parallel to XY? XY is this one. Which one is parallel to that? That must be this one, which is WZ. Alright, next one. What size is angle ZUY? Okay, let me rub this out. ZUY. So what's this angle here? Well, we know that the diagonals meet at 90 degrees. So all of these should be 90 degrees. So that should be 90 degrees. Okay, so ZUY is the 90 degrees there. How long is UZ? UZ, where's that? How long is a UZ? Well, we know that the diagonals of a rhombus will cut each other in half. So this length is the same as this length. Now, what's the length? What's the length of the whole thing? XZ is 24. We re-established that, so that whole thing is 24. So 24 divided by 2, this must be 12, and this must be 12. Right. So ZU is just 12, or UZ is just 12 centimeters. What size is XWU? XWU. So what's this angle here? Now, how do we work it out? We know that the angle, the whole thing is 135 degrees. And we also know that the diagonals will cut, here I'll show you, the rhombus. Diagonals bisect the angle at the vertices. So you see the angle at the vertices here, this angle here, 135. This is 135. The diagonals will cut it in half. So this will be that half and the other half there. So you do 135 divided by 2, and that'll give you 67.5. So that angle, if I'm not mistaken, should be 67.5 degrees. Alright, we're moving on to question 14. EFG is a rectangle. Okay, even easier. How long is DF? Well, actually, let me just first write in all the lengths. So we got FH is 14, so FH here. This one here. This is 14. Oops. Ah, that didn't. Okay, do it again. Okay, this is 14 centimeters, and angle DFG. DFG. Ah, this angle here is 70 degrees. All right. So angle DFG is 70 degrees. How long is DF? How long is DF? Ah, so I'll put that in blue. It's asking from D to F. How long is this? Now we know that the diagonals of a rectangle will cut each other in half, so that's the same distance there. Now we know that from here to here is 14. So half of 14 must be 7. So this must be 7 centimeters. Okay, so DF is 7 centimeters. Part 2, DG. DG. So that's that length there. That must also be 7 as well. The diagonals of a rectangle is going to be the same. So if this is 14, this must also be 14. And if this is 7, this must also be 7. Okay. It's pretty symmetrical that way. So this is 7 centimeters. DG is 7. DE. DE also 7 centimeters. And DH, where's DH? Oh, sorry, DE is this one here. That's 7 and that's also 7. Okay, there we go. 7 centimeters each. Now let's rub this out. Next question says, what size is angle DGF? So let's see. So nope. Okay. Okay, let's try again. DGF. So what's the size of this angle here? So I think it says. I think I'm missing something. Oh, right. We were told that this is 70 degrees, right? Let me just create a triangle here. We said this is 7 centimeters and this is 7 centimeters. So this length is equal to this length. What kind of triangle do we have now? Well, we have an isosceles triangle, which means that if this is 70, this must also be 70 degrees. This 70 comes from here. It states that angle DFG. DFG is 70. That's where it comes from. Okay, so they're both 70. So angle DGF is also 70 degrees. Part 2, moving across, angle FDG. I'll put that in blue. So FDG. Oh, yeah, hold on. FDG. Okay. So to find this last angle, we got 70 plus 70 is 140. 140, this one must be 40 because 140 plus 40 will make 180. And we know the angles of a triangle always add up to 180. Part 3, angle EDH. EDH. This angle here. So what is this angle here? Well, this angle, it's opposite this angle, vertically opposite, right? So what I mean by that is this, what I'll show you. So this angle here we discovered to be 40 degrees, and this one must also be 40 because two straight lines, when you draw two straight lines, the opposite angles of those two straight lines are going to be equal. These are called vertically opposite angles, so that's going to be 40 degrees. Angle DEH. Where's DEH? D, E, and then H. This one here. Well, these two are the same as well, so this must be 70, this must be 70. So that's EDH is 70 degrees. DHE. DHE, that's also going to be 70 degrees. Okay. DHE is this one here, I'll show you. DHE, this one. We know that's 70 because this one is 70 and this is an isosceles triangle and this is 40. EDH. DH. That's gonna be, wait, where is it? No, EDF, sorry, EDF. What's this angle here? Okay, well, we know that this angle, let's call it X, and this angle is also X. They're both the same, they're vertically opposite angles. Okay, so this is 40, this is 40, X and X. Okay, so 40 plus 40 plus with X plus X is equal to 360, the full revolution. This will be 80. 80 plus 2 lots of X is equal to 360. Let's work backwards and find out what X is. Okay, so 360, 80 plus what give me 360? Well, this one must be 200 and let's see, 60 minus 2, so this will be 80, 280 degrees. 80 plus 280 must equal to 360. Okay, so 2 lots of x will make 280. So that means x, we divide 280 by 2, you get 140. So, alright, so let me just put that in here. Now, that was a complicated thing to do. We know this is 4. Whoop. This is 40. Okay, this is 40. And this must be 140, and this must be 140. Because 280 divided by 2 is 140. These add up to 280. 280 plus another 80 is 360. That makes perfect sense. So, the angle EDF. This angle here must equal to 140 degrees. Angle DEF. DEF, where's that? That is, let me put it in red. D, E, and then F. Ah, okay. Right, so again, this is another isosceles triangle. That's 140, right? Now 140, so let's plus these two angles, which are gonna be the same because this isosceles triangle, are gonna make 180. So let's, I don't know, let's call that A, and that's A. So 180 take away 140 is 40. Okay, so these two must add up to 40, and they're the same. So 40 divided by 2, that means A must equal to 20. So what I'm trying to say is that this thing here, let me just rub this out. Okay, so we know this is 140. This must be 20, and this must be 20. Okay, this is an isosceles triangle. Okay. There you go, isosceles triangle, so that must be 20. Angle DFE, DFE, that's also 20. That's referring to this one here. Alright, next one is angle DHG. DHG, so this angle here. Okay, this angle also 20. You can also see that the top triangle and the bottom triangle is exactly the same. That's 140. Whoops. So these are all 20 as well. So angle HDG, HDG. Okay, that's 140. That's the angle here. This angle here. H, D, and G. So that angle there. Alright, there you go. All of the answers are there. I'll rub it all out. Alright, next one. We're up to question 15. We got a rhombus here. Angle EBC is equal to 30 degrees. EBC, where's that? EBC. This is 30 degrees. And, okay, that's all they give us. What size is angle BEC? BEC. Ah, what's this angle here? This one here. Now, what do we know about the rhombus? Let's have a look at the rhombus. The rhombus, the diagonals are perpendicular. So that means diagonals meet up at 90 degrees. Here, diagonals. These diagonals, they meet up at 90 degrees on all four sides of them. So that means that angle must be 90 degrees. Angle BEC is 90 degrees. Wait, I think that was 30, right? Yeah. BEC, that one there, that's 90. Okay, what else? Angle BCE. So BCE, this angle here. Okay, well, if that's 90 and you have a right angle triangle, okay, so that's 30, that's 90. What's the last one? Well, that must be 60. Because these three angles must add up to 180. Okay, so let me just get rid of that, and that can be 60. So BC, yep, that's 60. Angle CAB, CAB. What is this angle here? CAB. Well, we do know that this length is equal to this length. You can see that this is an isosceles triangle, right? And if this is 60, then this must be 60 as well. So that's also 60 degrees, CAB. ADB. ADB. So this angle here, let me put that in blue this time. ADB. Okay, so what's this angle here? Well, this you can also see is 90. This must be 30. And again, we have an isosceles triangle. What if I rub this out? You'll see it straight away. There you go. Whoops, what happened there? Alright. Wait, what? Okay. That's weird. Let me just get rid of that. I think my palm is causing it to... I'm writing on the screen. The palm must be causing problems. Okay, let's try it again. So if that's 30, you can see this is an isosceles triangle. This must also be 30 degrees. Okay. So where was I up to? ADB. ADB. Yes, this is 30 degrees. That's the one that's referring to this one here. Okay, next one is ACD. ACD. So it's talking about this one here. What's that one? Well, we know this is 90. We know that this is also going to be, they're all saying this is going to be 30 and that's going to be 60. So that's 60 degrees. AEB. Let me see. AEB, where's that? Let me just label all of them. 60, 30, this is 60 and 90. Alright, there you go. Now, AEB, where's, I'll put that in black, maybe. AEB, so this angle here, AEB, that's 90 degrees. ABE, oh my god, ABE, oops. So that was 90, now ABE, that's 30, you can see it from there, that's 30 degrees. Next one is BDC, BDC, that's 30, so that's BDC. DAC, DAC, and you can tell it's 60. And angle DAB, DAB, well, that's going to be 120, isn't it? 60 and 60 makes 120 degrees. There you go. That one's done. Let's go to the next page. Alright, let's see. We'll quickly do some of these. I'll start with question 2. The rest is pretty self-explanatory. I'll do one question of this one, just to help you out. Or maybe 2 questions. Alright. In the interest of saving time, I'm just gonna quickly use my calculator and just move on real quick. Okay, so this we're gonna start with this one here. This plus this plus this and plus this must equal to 360. So these one plus together, these 3 angles add together would give us 109 plus 38 plus 53 is 200 degrees. So all of these 3 angles is 200 degrees. This one, so to add with something else to be 360. So 360 minus 200, that'll be 160 degrees. There's your answer. Now this one, question M, same thing. 55 plus 45, that makes 100. 120. So 120, so 360, take away the sum of these, which is 120. So that'll be 200. So M is equal to 240 degrees. Alright, the rest you can do on your own. Question 2. Find the values of the pronumeral in each of these. So L. I can work out L just by doing 73 plus 89 plus 88. Okay, these three angles will create 250. 250 plus with L equals to 360. So what's L? So we just do 360, take away 250, and that's gonna equal to 110. So this would be 110. Now, the other one we want to find is the bottom one there, which is gonna be, so these two angles, let me just rewrite that. This is 110. Now 110 plus with this other angle on the other side will give us a full revolution of 360 degrees. So 110 plus with M is equal to 360 degrees. Now M is equal to 360, take away, just find a difference, and you will get 0, 5. That means M must equal to 250 degrees. And L is equal to 110. There's your two answers there. Okay, so first in question B, we have to work out what X is. So what's 25 plus 15? That's 40. 40 plus 60 is 100. So 360, take away 100. X is equal to 260 degrees. There you go. And also we know that X plus Y gives us a full revolution. So this angle X plus this angle Y gives us a full revolution. So 360 take away X will give us Y. So 360 take away 260, and that gives us 100. So therefore Y is 100. Because X plus Y must be 360. Okay. This one here, I can find out this angle first, S, because we know that S plus 154 makes a full revolution. So we do 360, take away 154, and you're gonna get this will be 6, this will be 0, this will be 106. S is equal to 106. 106 plus these three angles must give you 360. So we can work out T now, right? You can say 106 plus with 14 plus 55 equal and plus angle T is equal to 360. So there's only one number there. You have to work it out. I'll leave that to you. Question 3. Find the values of all pronumerals in the following. Okay. Now let's look at this bottom one here. 120 is this angle here. 120 plus with this angle D makes a angle of a straight line, and we know that the angle of a straight line is 180 degrees. So D must be what? So 120 plus what gives me 180. So this has to be 60. Now if we have 60, you can use this four-sided shape to work out what angle E is. Okay, so 70 plus 60 is 130. 130 plus 140 is 270. So 270 plus with the last angle E will give me 360. So therefore E is equal to 360, take away 270, and that's going to give us what? 90. So E is equal to 90 degrees. Alright, next one. So D is equal to 60, E is equal to 90. Alright. Question B. Now we got 130 degrees and 90 degrees. You can work out angle G. So 90 plus 30 is 120. These two becomes 120. 120 plus 105 becomes 225. 360 minus 225, you're gonna get, this will be 5, this will be 3, and this will be 1. 135. So therefore G must equal to, so this angle here, angle G, is 135. Alright, now how do we get angle H? Well, we know that G plus H makes a straight line, which is 180 degrees. So 180 take away 135 will become 45 degrees. So therefore H must equal to 45 degrees for these two to add up to 180. Okay, next. Alright, we can look at this and we can work out the angle R straight away. We can say, well, we know that angle R plus 150 makes a straight line. And we all know that a straight line is going to be 180 degrees. So this one must be 30 degrees, because 30 plus 150 will make 180. And if you have 30, you have a four-sided shape here. Okay, this is 30. You can find out S. I'm not going to do that for you, so you can do that yourself. Question 4. Find the values of all the pronumerals in each of these. Okay, so first we're going to find out this angle here. You can see that that angle is inside of a four-sided shape. So these four angles must add up to 360, a total of 360. So let's do a little calculation. The 105 plus 115 plus 80. This will be 0, this will be 0, and this will be 3. Alright, 300, which means this will be 60 degrees. Because 300 plus 60 will make 360. Now if that's 60, what is this angle here? Let me just rub this out, I'll show you. Okay, so this angle here is 90 degrees. You can see by the 90 degrees symbol there. Now this is 60. We just worked it out, right? If that's 60, 60 plus what gives me 90? This has to be 30. Done. Alright, here we go, another one. What's this angle D here? We have to work it out. 119 plus 37 plus 152. Let's add these three together first. Okay. 9 plus 7, 16. 16 plus 2 is 18. This will be 2, 5. 5 plus 5 is 10. 308. So 360 take away 308 will give me 52. So angle D must be 52 for the sum of all these four to be 360 degrees. Now we do know that this angle here is 90 degrees, marked by that little box there. Okay, so if 52 plus with E, so 52 plus the angle E is equal to 90. So E is equal to 90, do a subtraction to find the difference. Minus 52, and E is equal to, is it 40? No, 38. There you go. So E equals to 38 and D is equal to 52. Alright, last question here. C, well, let's have a look here. We know this is 63, right? It's not to draw on the scale. But if that's 63, then what's U? We know that U plus the 63 is going to give us 90. So 90 take away 63 and that'll give us 27. So U must be 27 degrees. And if you have U, then you can get the other lengths there. You can get the V. I'll let you work that out. Just make sure they add up to 360. That's all. Alright, next one. Find the value of the pronumerals. Okay, so now we can look at this question and we can work out angle C straight away. Well, not straight away, but relatively quick. Okay, so we add all these together. So let's see, what's 65 plus 115? That will equal to 180. 180 plus 100 is 280. So together, all of these three angles is 280. C must be 360 minus 280, which means C must be 80 degrees. Now if C is 80 degrees, okay, C, so I'm going to write here C is equal to 80 degrees. That means D must also be equal to 80 degrees. And why is that the case? The reason for that is because when you have two straight lines, could be like any, right? The opposite angles of this on the other of these the two straight lines are going to be equal. Can you see here we got two straight lines? So that means that angle C is equal to angle D. So if angle C is 80, then D must also be 80 degrees. Alright, let's look at this one here. You can see here we got two straight lines. This is 85 degrees, which means this should also be 85 degrees. And if you can find that that's 85 degrees, you can work out the letter N. Make sure N plus with all of these ones make 360, that's all. Now let's look at this one. If this is 60, this must also be 60, and now you can get angle Z. Okay, so 42 plus 60 Let's find out what this is. This will be 4. This will be 14. So all of these three angles add up to 114. Now work out what Z is. So do 360, take away 144, it's not 140, 144, and find out what Z is. That's all. Alright, next question. Question 6. Find the values of the pronumerals in each of these. Okay. So let's look at the first one. What we're going to do is we're going to recognize that this is 90 degrees. This is 140 degrees, and this is an unknown value. But what we do know is that these three angles add up to 360 degrees because it's a full revolution. Okay. So let's just add these two first. This is 90. 90 plus 140 degrees will be 230 degrees. Oh, and then all we got to do is do 360 minus 230 and you get 130 degrees. So the P must be 130 degrees. Okay, so you got 120, 130 and 70. These two add up to give you 200. 200 plus 120 must be 320. So together, these three, let me just be messy here. So this angle plus this angle plus this angle is 320. The last one is what? What plus 320 is 360? Oh, that must be 40. Okay. The reason add to 360 is because these four angles lie inside of a four-sided shape. Question B. We know this is a revolution angle here, so we can work out the U, the angle U. So 133 plus 107 becomes 10. This will be 4. This is 240. Okay, so 360. Take away that 240, and you're gonna get 0. This will be 1, 2. So this must be 120 to make a revolution. Okay, now you got this will be 90 degrees. Okay, so 90 plus 120 plus 125, you can work out what V is. Question C. Let me see. We can work out this angle here, okay? Because you got a four-sided shape. Okay, so let's add these together. 70, let me see, 79 plus 94 plus 76. This will be 10, 19. This will be 10, 17, 24. Alright, so 249. So these three angles out of 249. What's the last angle? What's X? Well, we do 360, take away 249. What do we get? We get 1. This will be a 5. This will be a 1. 100. So X must be 111 degrees. Now you got to find out Y. Alright, so we know that X, the X degree plus with 160 plus Y makes 360. So let's add the 111 to 160 first. This will be 1, this will be 7, this will be 2. So together they make 271. Now we have to add one more. So 271 plus the last angle Y is equal to full revolution of 360. So to find Y, we just do 360 take away 271. Work it out yourself. No, I'm not gonna do all of it for you. Question 7. Find all the pronumerals in each of the following. Okay. Now we have to understand how parallel lines work. The parallel lines and the transversal. Alright. So here you got two parallel lines. I'm gonna color the transversal in blue so you can see. Right. So you got two parallel lines and a transversal, the line that goes through the parallel lines. Now we have the three rules when we have this kind of setup. All the acute angles are the same. All the actually I might write it down somewhere. Okay. So the rules are all acute angles are the same. Oh, I have no space. All obtuse angles are the same. Acute, any acute plus obtuse equal to 180. Alright, here let's have a look. This is an obtuse and this is an acute. Okay, well they must add to 180, so this must be 70. If that's 70, then we can find out what this is. We can look at this shape here. It's a four-sided shape. That's 7. This is 120, 80, 70. You can work out what the last one is. Alright, these four angles must add up to 360. Okay, I'll let you work on that. Next question. Alright, again you got two parallel lines. Actually, let me extend that. That's a parallel line there. Whoops. Another parallel line there. And now for the transversal line, I'll draw in blue. Now this, whoops. Okay. Now this angle is 31 degrees. It's an acute angle. If that's an acute angle, look at J. J is also an acute angle. And what did I say? I said all acute angles are the same. So, if that's 31, then J must also be 31. You got two parallel lines and a transversal line. You got two acute angles, then they're both going to be the same. So now if we know that that's going to be 31 degrees, we can work out this four-sided shape. Alright, so this is 31, that's 147, that's 126. You can work out K by yourself. Just add all of these three angles and then do 360, take away the sum of these three and you will get K. Alright, next one. Let me see, I'm going to draw the parallel lines again. Okay, so here's your two parallel lines. Alright, and then you have a blue transversal line. So here's a transversal line. Alright, so we know that all the acute angles are the same and all the obtuse angles are the same. Here you have an obtuse angle and here you have another obtuse angle. So these must be the same, which means this must be 97 degrees. Alright, now I know that's 97. Let's work out this last angle here inside this four-sided shape. So here's your four-sided shape. Okay, so let's work it out. We got 55, 86, and 97. So 55 plus 86 plus 97, what do we get? Okay, this will be 11 plus 7 is 18. This will be 10, 18, 18 plus 5 is 23. 238. So what's this last angle here? So all we got to do is do 360, take away 238, and you're going to get 2. This will be a 4, this will be a 2. 122. That means this angle, whoops, this angle must be 122 degrees. Okay, now we know that that angle plus this angle, angle B, it's gonna make a straight line, which means that this is 180 degrees. So 122 plus with this angle B is equal to 180 degrees. Okay, so to find angle B, we just do a subtraction. B equals to 180, take away 122. This will be 8, this will be 5, so this will be 0. So 58 degrees, B is equal to 58 degrees. Hope that makes sense. Alright, let's look at question 8. Someone keeps calling me. Okay, put this on silent. Where is the silent? Ah, here we go. All right. Next one, question 8. Use the properties of the special quadrilateral to find all prime numerals in each of these. Okay. Alright, so let's have a look at this one. Okay, so if this is 55, this is going to be what? This is a parallelogram, by the way. This shape here is a parallelogram. So parallelogram, let's go back to the other page. What do we know about the parallelogram? Well, we know that where is it? Ah, yes. Opposite angles are equal. Aha. Alright, let's go back to this one here. Oh, wrong side. So here's a parallelogram. Opposite angles are equal. Ah, here we go. This is opposite angle and this is an opposite angle, which means they're equal. So this must be 55 degrees. Okay. Now if that's 55, what's this one? We know that this is okay. This is so the angle A plus the angle B makes a straight line, and a straight line is always 180 degrees. So we know that we have angle A already. This is 55 degrees. Now angle B, 55 plus what gives me 180? Well, we just do 180, take away 55 degrees, and that's going to give you 125 degrees. Now once you have angle B, you can find angle C, because angle C is it lies inside this quadrilateral, this four-sided shape. So let's work it out. We got 125 plus 106 plus 42. Let's work out these three angles first. 1, 2, 3. Okay, so this will be 11. 11 plus 2 is 13. 3 plus 4 is 7. This will be 273. Now 273 plus this angle C is 360, so we need to find angle C. So just do 360 minus 273. This will be a 7, this will be an 8. 16 minus 8 is an 8, and that'll be 87. So C, 87 degrees. Done. Alright, we're nearly there. We just got 3 more questions to go. Question B. Let's see. This is a square, as you can see. So let me see. What can we say about this one? First of all, this angle G. You have the diagonal of a square will cut the angle in half, okay? And we know the angle is 90 degrees. This is 90 degrees. If we cut it in half, we're going to get 45 and 45. So therefore G must equal to 45 degrees. Now, this is a 90 degrees right here. So you got, what else you got? Okay, so you got 90, you got 130 and 45. So 45 plus 90 plus 130. So this will be a 5. This will be 13. 13 plus 3 is 16. So that will be 265. Okay. Now the reason I did that, I'll just show you real quick. Okay, we worked out that this is 40. Whoops, let me just write this here. This is 45 degrees. And inside here you have a four-sided shape. This is 90 degrees. That looks bad. Okay, how about this? Yes. So therefore these 4 angles, 45, 90, 130 and H must give you 360 degrees. We worked out the 3 of these add up to 265. So let's work out H. H is equal to 360, take away 265, and that's going to give you a 5, this will give you a 7, this will give you a 9, this will give you 95 degrees. So H is equal to 95 degrees. So G is 45, H is 95. Okay. Now question C. We're gonna do this one now. This is the easiest one right here. This you can tell it's a rectangle, right? All of the angles of a rectangle is 90 degrees. So you is instantly 90 degrees. Don't need to do anything. Alright, now we got, what else do we have? We have 153 plus this angle T. These two angles add up to make a full revolution. So this angle plus this angle makes a full revolution, which is 360 degrees. So we do 360. Let's take away that 153 to find out what the angle T is. This will be an 8, this will be a 6, a 0, and then this will be a 2. So that means T is equal to 208 degrees. Right. So here you have a 1, 2, 3, 4. Oh, that didn't go well. Okay, this one. Okay, you got a four-sided shape, which means that all of the angles must add up to 360. Okay, we've got U, we got T, we just need to find V. So we know that the angle U plus angle T plus 44 plus angle V is equal to 360 degrees because they're all inside a four-sided shape. Now U is equal to 90, T is equal to 208 and 44. Okay, let's add them together. Okay, I'm gonna add it downwards, so let me just add it like this. 90 plus 208 plus 44. Let's see what that gives us. This will be 12. This will be 10. 10 plus 4 is 14. This will be 342. Alright, now the V, we have 342 plus V, the last angle was 360. So we do 360, take away 342, and what that gives us 8. This will be a 5, this will be a 1, so 18 degrees, done. So V is equal to 18 degrees. Okay, last question. Let me just get this one. This is too big. Shrink it down to size. Move it here. Alright, question D, last one. This one looks tricky. Now, in order to do this, we have to understand that this is a, what shape is it? It's a rhombus. Okay, so with a rhombus, when you have a rhombus, the diagonals of a rhombus will bisect each other, will cut each other in half. So that diagonal will cut this one in half, and this diagonal will cut this one in half. So what you get is this, like that, see? Now, not only that, but the diagonals also cut the angles in half. So that angle becomes half. So let me just redraw that. So this angle is equal to this angle because the diagonal, here's a diagonal, it cuts the angle in half. Now if you wanna, you can go back and read this one here. Let's have a read here. This is a rhombus. Here we go. Oops, that did not go well. Okay. Whoa. Okay, as you can see, it says here, diagonals bisect. Bisect means cut in half. The angles at the vertices. See? So, if you go back to the question, this diagonal, whoa, this diagonal is going to cut this angle in half. Alright, so, whoa, let's go back here. Let me do it over that one. So that means that this is 124, so we cut it in half, we're going to get 60. Excuse me. This will be 62. This will be 62 as well, so if you draw a line there. Now we also know that the opposite angles of a rhombus are equal. So this is also, if that's 124, this is also 124, and then we divide it by 2. So that means that each angle is 62. That's 62 and that's 62. Right, so that helps us a little bit, doesn't it? Look, let me just rub this out. What do you notice? You notice that I got one of the angles already, huh? Angle D. Angle D is equal to 62 degrees. Just because we do 120, 124 divided by 2 and you get 62. So this is 62. There you go. Now, what else? What do we know about diagonals when they meet? What do they meet at? They always meet at 90 degrees. So C must equal to 90 degrees. So C is equal to 90 degrees. Now, I'm going to redraw this shape. So help you to see. So this shape here, I want to redraw it. So it looks like this. So it looks a bit bigger. Okay, there's 90. There's 71. There's angle E. And angle D was 62. So you can work out what angle E is. Angle E is the last one. Okay, we know that these four angles must add up to 360 because it's inside of a four-sided shape known as a quadrilateral. So we do 70, let me just work it out, 71 plus 90 plus 62. That gives us 3. 7 plus 6 is, sorry, 7 plus 9 is 16. 16 plus 6 is 22. So that gives us 223 degrees. Now, to find angle E, we say 360 minus 222. And that will give you 8. This will be a 3. This will be a 3. 6 minus 3 is 3. And then that'll be 138 degrees. And you're done. All the questions are done there. Hope that helps.